Hi, Dr. Tran. This final presentation for our design project will only be covering our final design of the automated Ambu bag. Details about our overall design process is covered more in depth in our report. If you have any more questions about our design after this presentation, please look in our report for more details or email us. We divided our design into 3 subsystems: the face mask, the breathing mechanism, and the protective casing that encloses the breathing mechanism. First, we have the face mask. The face mask of the Ambu bag is how the patient directly receives oxygen. We kept the design of the face mask relatively the same as a regular Ambu bag, except we added straps so that the first responder can be completely hands-free. With a manual Ambu bag, the person in control has to hold the mask onto the patient's face in a way that forms a seal so that air can't escape. In order to mimic these conditions, we decided to add adjustable elastic ear straps to form the seal. We decided to attach the straps to the ears as opposed to around the head so that the first responders don't risk intensifying any possible neck or spinal injuries a patient might have by moving the head. The mask also has a PEEP valve and an expiratory valve to control airflow, and the mask is also connected to an air tube that connects to the squeezable bag in the breathing mechanism.
The breathing mechanism for our Ambu bag is going to be powered by 2 slider crank systems, one on each side of the Ambu bag, and they're going to function to compress the Ambu bag and release it in order to simulate the breathing action of a patient. The slider cranks are composed of a servo motor, a crank, an attached rod, and a piston at the end of that rod, which will be making contact with the Ambu bag to compress it. Of course, there's the inflatable bag of the Ambu bag. The Ambu bag will be suspended by 2 supporting stands with clamps to hold the Ambu bag in place. There'll be tubes extending from each end of the Ambu bag, since it has to be fed outside of the protective casing to the patient and on the opposite side to receive oxygen from the atmosphere. There is an air inlet and pressure release valve on the inlet side of the Ambu bag, which is connected to the tube outside of the protective casing. Right after this air inlet and pressure release valve, there is the reservoir bag, which holds the excess oxygen that is taken in through the air intake valves. There's also going to be 2 one-way valves for air release to the patient as well as to the atmosphere, and that is on the outlet side of the Ambu bag, outside of the protective casing and connected to the face mask. So the servo motor will turn the crank, and then that will cause the rod connected to the crank to move the piston in and out of compression with the Ambu bag.
The third part of our Ambu bag is the casing. We decided to make the casing out of twin-wall plastic, which is a durable, water and weather-resistant material. This plastic is also easily cut and will cover the breathing unit and protect its components inside. In the casing, there are 2 holes on either side to allow both tubes to connect to the valves outside the box. We then decided to add 2 handle straps to the top of the rectangular case to be easily held and transported by the first responders. Finally, we attached 4 rings to the outside of the plastic case. This can be attached to the ambulance wall via straps, making it easily stored.